Welcome guys. Here's another video for lesson plan D. From the previous video, I've been able to generate the reduction formula for integral of tan nx dx. Now here in this video, I would like to show you how to generate the reduction formula for cot nx dx, and then in the next video, I'll try to integrate I'll try to generate the reduction formula for sec nx and cosec nx also. So taking this, we have the first one here, the solution for the fourth part, which is the integral of cot of nx dx. Now here in this case, remember the steps. The first thing I ask you to do is we let in represent the question given to us, which is cot of nx dx, right? And at the same time, I said you can write this in another format here such that n is greater than or equal to 2. N is a positive integer, but the condition is that n is greater than or equal to 2. Then for n to be greater than or equal to 2, that means we will end up having cot of n minus 2, right, of x times cot square of x dx. So this is what we're going to have. So this is what we have. So yeah, in this case, since we have this, okay, let me just recall you back to this. Remember that from trig identity, 1 plus cot square x gives cosec square x, right? Remember that it gives us cosec square of x. Hence, by the time we make cot square of x the surrogate of the formula, we end up having cosec square x minus 1, right? So since we have this, we can easily substitute. Hence, in equals integral of what? Cot of n minus 2 of x multiplied by this cot square x is now cosec square x minus 1. Then remember that there is a dx there. So when you continue with this, we have to open up this bracket. So if I open up this bracket, I'll end up having okay, let me write it here. When you open this up, I'll have integral of this times this dx, that's cot n minus 2x cosec square x dx, then minus integral of cot n minus 2 of x minus 1 times minus 1 times dx, that is, the minus is already here, this times 1 times dx, that should be cot of n minus 2 of x dx. So we have this. Next thing to do is that we believe that this is already in minus 2. From our assumption, in is cot nx. So automatically speaking, integral of cot n minus 2 of x dx is also in minus 2. So we don't have any business with this. So we need to simplify this by making use of IBP, that's integration by parts. So using integration by parts, remember that we always let u represent the first one you have here, that is cot of n minus 2 of x dx, and at the same time we make dv represent the remaining expression, so that is cosec square x dx. Sorry, okay, there is no dx here, just cot n minus 2 of x, while the remaining part is for dv. So remember that for an integration by parts, the whole of this simply implies uv minus integral of v du, right? Then remember that I have minus, the whole of this is in minus 2, right? So all I need now is u. I know what u is all about. I know the expression for u. I want v, but there's no v, right? So and I also need du. So to get du, that's very easy to get. Du will be equals to this n minus 2 comes down. So when you differentiate cot x, if I differentiate cot x, the result is minus cosec square x. Yeah, that should minus cosec square x. And then repeat everything back. That's cot, but you must subtract 1. Minus 2 minus 1 of x, right? So then if I integrate both sides here, then if you integrate dv, you have v. When you integrate cosec square x, there is no, okay, what if I decide to say, okay, let me put a negative sign outside, then integrate minus cosec square x, so that I can easily have my antiderivative easily. So that's minus. You know, if you differentiate cot x, you have minus cosec square x. So if you're now integrating minus cosec square x, I will have what? Cot x. So that's minus cot x. So that's the concept. This is the concept here. So then I know what my d is all about. So I can substitute. I can go ahead and substitute. In equals to this u we have here. U is this cot of n minus 2 of x, right? Times v. V is minus cot x, right? Next thing is minus. No, this is multiplying each other. Take note. This minus is separate. Integrate v, which is minus cot x, multiplied by du. The du I have here now, see the result here. Du now I have minus, I'm writing it out, minus n minus 2. Okay, then I have times cosec square x. Then I also have times cot of n minus 2 minus 1, that's minus 3 of x. Remember, it is du over dx. When you cross multiply, or you multiply by 1 over dx, but if you multiply by dx, you have this. You have all this expression on the right hand side times dx. So don't let us forget this. Okay, the whole of this is uv minus integral of v then du, right? So remember that we have minus of in minus 2. So let's put that once and for all. So next thing to do now is that we have in equals, so here in this case minus times, I have minus cot x. Okay, I should have done this straight up. Okay, no problem. Cot, I want to multiply this power together, this two product. So let me just write it out. Okay, so here I have minus minus minus, that gives minus. Then I'll have integral of, if this multiply this, I will end up having cot. You know, there's 1 here, minus 3, that's n minus 2 x, right? And then I have cosec square x left, then dx minus in minus 2. So it's making sense. Then in equals, so if I multiply this now, so clearly, trivially, I have minus cot. I have 1 here, 1 minus 2, that's n minus 1 of x, minus, here now we'll be having integrate cot of n minus 2 of x. Remember the expression for this from trig identity. Cosec square x is what? Cosec square x is equals to 1 plus cot square x. So I'll substitute it here. 1 plus cot square of x, then dx, then you close the bracket, and then we have in minus 2. So therefore in equals minus of cot n minus 1 of x, right? So straight up, I want to expand, I want to open up this bracket, everything. I want to open up this integral rather. So I have minus integral of this times 1 dx. I will have minus integral of cot n minus 2 of x times 1 dx, that's dx. Minus times plus is minus integral of this cot square x dx. If this multiply this, if this cot multiply this cot, based on the powers, minus 2 will cancel 2. I will be having cot nx left, then with dx, right? Then minus in minus 2. So I'm almost close to the final answer. This is equals to minus cot n minus 1 of x minus this, clearly seen, this thing implies in minus 2. Yes. But remember we have, oh wow, that's nice. So I've been looking at this morning. We have this n minus 2. So it is not stated. It should be outside here. N minus 2, n minus 2, n minus 2. And also there's n minus 2 here. N minus 2 is multiplying the two expression. Minus n minus 2 of this multiplying this. So I should have n minus 2 here also. So I'll be having minus n minus 2. This cot nx is in. Okay, sorry for the mistake. In, then finally with this in minus 2. So I have in here. This in and this in mix up together. So when this goes like this, I'm going to be having in. I will have in, right? This comes like this plus n minus 2 of in equals, here in this case I'll be having my negative of cot of n minus 1 of x. Then remember I still have minus n minus 2 of in minus 2 with this last term here, in minus 2. So next thing to do now is that we factor out in, and I'll have 1 plus n minus 2 minus cot n minus 1 of x. Minus is common here, and then we factor out n minus 2 also, leaving us with n minus 2. Then minus times plus gives us this back, or minus and minus is plus, and I have 1. So here in this case, 1 minus 2 is minus 1. I have n minus 1 equals minus cot of n minus 1 of x, right? And then minus in minus 2, n minus 2 plus 1, that should be n minus 1. Yeah, that should be n minus 1. So I can divide through by what? From here now, I can decide to divide through by n minus 1. So on dividing through by n minus 1, from here now, divide through by, okay, let me write this out. In of n minus 1 equals minus cot of n minus 1 of x, in minus 2, n minus 1. So if I divide through by n minus 1, n minus 1, n minus 1, this cancel this, I have in equals minus 1 over n minus 1. You get that? Is common. I think minus is common to the two terms. Let's factor it out. Okay, minus is common. Yeah. Okay, but this cancel this. So that means I can factor it out for the two of them. So then this should be cot of n minus 1x only. I'll prefer to use this. So let me leave this as minus of in minus 2. So this gives the final answer for in. Hence, the integral of cot of nx dx will end up giving us, the two of them will be minus, negative sign, minus 1 over n minus 1 cot of n minus 1 of x minus n minus 2. So this gives the final result. Thanks for watching. Please remember to subscribe to my YouTube channel. Thank you very much. See you in the next video.